relative motion between two projectiles. That means just like we need to answer, there will be some theoretical questions based on that. When you are observing the one projectile from the other projectile, what will be the nature of that path? How it appears to be moving in that other projectile if you are observing from another projectile here. So for that we are considering these two projectiles like this. One is projected with initial velocity at an angle alpha 1, and other is projected with initial velocity u2 and at an angle alpha 2 with the horizontal. And for both of them the acceleration will be same. So the relative acceleration will be acceleration of 1 with respect to 2 will be acceleration of 1 minus acceleration of 2 you can write. And so that relative acceleration will be 0. That means there is no any relative acceleration for these particles in this case here. And so now just let us write this velocities here. And so now the velocity of this first one with respect to this x we can write it. That means x component we can write as u1 x is equal to u1 cos alpha, and u2 x is equal to the u2 cos alpha 2. That means the x component of the second projectile. Similarly the y component u1 sin alpha 1, and this is u2 sin alpha 2. So u2 sin alpha 2 is the y component of the second particle here. Now let us write horizontal relative velocity along this horizontal direction here. So if you are finding this relative velocity along this horizontal direction, then you can answer like you can write this as u1x minus u2x. And so therefore this value you can write this as u1 cos alpha 1 minus u2 cos alpha 2. And similarly like this value we can write this as u1 sin, that means y component relative velocity along y direction we are writing here u1 to y, then u1y minus u2y you can write here. Therefore this is u1 sin alpha 1 minus u2 sin alpha 2. And here these are the velocities along x and y directions, and here we are concluding that there is no velocity acceleration, relative acceleration for these two particles here. Then you can write this, these two particles appears to be moving in straight line, right? Because there is no acceleration, they are having some velocities and they are continuing to move with that velocity there, right? And actually you can also discuss this in another way here. So for example, as we discussed there, if I am writing displacement of x and displacement of y, you can write in terms of that also you can express here. Suppose I am writing this x displacement of this first one, u1 cos alpha 1 into t, and x displacement of the second one, u2 cos alpha 2 into t, right? And let us write similarly the y displacement of this first one here. So u1 sin alpha 1 into t minus of gt square. Similarly the y displacement of vertical displacement of the second particle. So u2 sin alpha 2 into t minus of gt square. Now we can also express this as like suppose if I am writing like y2 minus y1 is equal to. So y2 minus y1 means then this of gt square term will be cancelled and t you can take common. So you can write this expression as u2 sin alpha 2 minus u1 sin alpha 1 of t, right? Let's suppose say this is the equation 1. And then you can also write this as x2 minus x1 value. So x2 minus x1 value, similarly you can write this as u2 cos alpha 2 minus u1 cos alpha 1 into t. This is say suppose say equation 2. These are the relative displacement of, that means of what we are writing is the displacement of 2 with respect to 1 we are writing here, right? And so relative displacement, if you are finding the ratio of these two here, suppose like I am writing like y2 minus y1 by x2 minus x1. So then this t term will be cancelled, so that you will get this equation as u2 sin alpha 2 minus u1 sin alpha 1 by u2 cos alpha 2 minus u1 cos alpha 1, right? And so now we can observe that this is now independent of this t here. This t term will be cancelled, so that you will get some constant value here. So right, this value is a constant. That means this y2 minus y1 by x2 minus x1 is a constant value. So this is nothing but actually our slope form here. So right, and so then the slope is constant in the sense you can say that that will be a straight line here. So that means when you are observing this particle 2 with respect to 1, it appears to be moving in a straight line, having this much of slope here, which is a constant and independent of this time here. And so that then we can say that with respect to this first particle, the second particle appears to be moving along this straight line here. So which we can mention like this, or we can express like this. It appears to be moving along this straight line here. So that means now it is that means with respect to, either you may consider that 1 with respect to 2 or 2 with respect to 1 you may consider here. So it appears to be moving along this straight line there, right? So that is from this what we can conclude is when you are observing one projectile with respect to the other projectile, it appears to be moving in a straight line, not parabolic path. With respect to the ground, we know that the projectile is follows a parabolic path here, but whereas with respect to another projectile, if you are observing here, it appears to be moving in a straight line path. And in that straight line path only, here you can conclude that one more conclusion here. If suppose these horizontal components are equal, so that means here if u1, so like if u1 cos alpha 1 is equal to u2 cos alpha 2. If this happens here, then you can observe this slope will become infinite. Slope is infinite means then it is nothing but a line parallel to this y-axis you will get. That means this line appears to be a vertical line here. So this line will be a vertical line. That means the other particle appears to be traveling along this vertical line here. If it is non-zero, if both the horizontal components are different, then it appears to be moving along a straight line having some slope. But whereas if horizontal components are same, then that indicates that horizontal components are same means horizontal displacement is same for both the particles. So that means if you are observing one particle with respect to other particle, it doesn't have any horizontal component, horizontal displacement. So always it appears to be moving along this vertical line only. So that is another point you need to remember here. So that means the motion will be along this vertical line. So that is nothing but what we are giving here. So if u1 cos alpha 1 is equal to u2 so this is if u1 cos alpha 1 is equal to u2 cos alpha 2, then you can say that relative motion is along y-axis or vertical line. Similarly, if u2y is equal to u1 to y is equal to 0, that means if vertical components are same, then it appears to be moving along the horizontal line. If vertical components are same, then both will be at the same height at any instant. So they appears to be traveling only along this horizontal direction there. So their motion will be only along this horizontal direction like this. One particle will appear to be moving along horizontal direction with respect to this other particle there, right? So that is this relative motion here. That means from this what is our conclusion is, if you are observing a path of a particle projectile from other projectile, it appears to be moving along the straight line. If their initial horizontal components are same, then it appears to be vertical line. If the vertical components are same, it appears to be horizontal line. If both are different components are there, both the horizontal and the vertical components are different, then it appears to be just a straight line having some slope, right? So that is about the relative motion between these two projectiles here. And so next let us come to this another important condition here, the condition for collision between two moving particles. So sometimes a collision in projectiles we already discussed in our previous classes. So that means here this is a general condition here. If sometimes they may give the two particles and whether they may ask that whether the two particles are colliding or not. Or they may give that if the particles are colliding, they may ask about the velocity of the other particle by giving velocity of one particle, or sometimes they may ask about the direction of the other particle there. So right. So that means they may ask about the direction of the other particle, or they may ask about the velocities there. So the only condition whenever two particles are colliding, let us consider here. For example, this one particle is moving along this line here. It is having some velocity say along this direction, and suppose that means its path will be along this direction here. It is moving along this direction. And now suppose another particle is moving along this direction here. So that that means its path is, it follows a path like this. So right. So now here our question is, if suppose these two particles are moving like this, suppose say this is particle A and this is particle B. If the two particles are moving like this, whether the two particles collide with each other or not. That means if suppose their paths are intersecting at this point here. If the paths are intersecting, from this you can't conclude that those two particles will collide, right? because this particle, suppose say I am naming this point as some O here. This particle A may reach the point O earlier than that of B, or B may reach the point O earlier than that of A. That means if both the particles are reaching that point O at the same instant of time, then collision is possible. If both are reaching that point at the different instants of time, then collision is not possible, right? And so to make sure that collision is possible or not, the general condition is both should reach that point at the same instant of time. That is our general condition. So, but here with the help of this relativity, what we can conclude is, if you are finding that velocity of one object with respect to the other particle, if you are finding velocity of one particle with respect to the other particle, if they are directed towards each other, if the relative velocity of one particle with respect to the other particle is directed towards each other, then collision is possible. If it is along any other direction, then collision is not possible. And so, like suppose if this is nothing but what we are mentioning here, if two particles are moving with uniform velocity such that the relative velocity of one particle with respect to the other is directed towards each other, then they will collide with each other, right? So otherwise collision is not possible. That means here for this what should happen is the velocity of A, if you are finding for collision to happen, the velocity of A with respect to B must be directed towards this B here, or velocity of B with respect to A must be directed towards this direction here. If suppose that relative velocity is along this direction here, if it may be velocity of A, if you are finding, you may find velocity of A with respect to B, or you may find velocity of B with respect to A. If the relative velocity is along the direction there, if the relative velocity is along the direction, along the line joining the two particles, then collision is possible. If the velocity is along any other direction, if suppose velocity, this relative velocity is not along this line, if you are getting this relative velocity somewhere along this direction here, the relative velocity, like suppose then collision is not possible, because we here suppose if you are finding that, if you are assuming that velocity of A with respect to B is along this direction, if you are considering here, then velocity of A with respect to B is along this direction, means what we are considering is B is at rest. According to that, B is at rest, then A is moving along this line. So if B is at rest and A is moving along this line, then definitely particle A will collide with the B. But suppose if the relative velocity of A with respect to B is obtaining along this direction here, then B particle will remain at rest here, then A is moving along this direction, then it doesn't collide with that, right? So then this particle will move, continues to move along this line. Like in the previous class we discussed the shortest distance. Then you can find that shortest distance between particles A and B in such a cases. So but here the collision to takes place, the shortest distance between them should be 0 when the collision is taking place, so that the particle velocity must be directed like this. And basing on this only, sometimes you have heard that the earth just missed a comic or a astronomical, some particle is moving very close to the surface of earth. They may hit it or not, that depends on this their relative velocity concepts only. Suppose say the earth is moving along this direction here, it is moving in its orbit around the sun, and suppose its velocity is along this direction here, this is the velocity of the sun. Some astronomical object is moving along this direction here, suppose it is moving along this direction with some velocity v0, let us consider here. So now whether these two particles are hit or not means that depends on this. This velocity of this particle will be like this. So that means now at this point they are intersecting with each other. So just if the paths are intersecting at this, if the paths are intersecting, then you can't conclude that collision will take place, right? Because when this particle reaches, the astronomical particle reaches this point, the earth may cross that point or earth may not reach that point, right? It may be late, or it may cross that point before that particle reaches that point. So then collision is not possible. If both are reaching that point directly, then only collision is possible. So that also we can measure by using the same concept here. So if you are finding this velocity of earth with respect to this particle, or velocity of particle with respect to this earth, if that velocity is along this direction here, if suppose if you are finding this velocity of this particle with respect to this earth, if it is directed towards this earth here, then collision will be possible. We are finding velocity of particle with respect to earth, means we are assuming that earth is at rest. Now the particle is moving towards the earth, and so definitely collision will take place here. So that means such a you can sometimes in the newspapers you can observe such a news there, like the earth misses that means the particle misses the earth just by a few kilometers or few thousand kilometers or few hundred kilometers, right? So that is that we can do this calculation by using this method only. So right. So let us go to some numericals based on this concept. So this is the only condition for the collision to take place here. So let us see one numerical based on this. And so now let us see this particle here. Let us see this problem here. Two particles are projected vertically upwards from the point O comma, that means 0 comma 0 and 1 comma 1 with the velocity is 10 meter per second and V meter per second respectively as shown in the figure. It is found that they collide after some time t in the space. Find the V and t values. So here it is given that already the particles are colliding with each other, right? The particles are colliding with each other means the velocity of one particle with respect to the other particle must be directed along the line joining those two particles there. So right, so let us write the velocities values here. So I am writing this velocity values here. Suppose I am naming this particle as suppose say A and this particle is, let us take it as B. So now I am taking this velocity of A in vector form. Let us write here. So 10 cos 30 10 root 3 I cap plus 10 sin 30, that sin 30 is 1 by 2 j cap, and so which you can write this as 5 root 3 I cap plus 5 j cap. So this is the velocity of A. Next let us write velocity of B, and so then it is V by root 2. You know the components resolution. I am directly writing like this because that angle is given as 45 degrees. And so now let us find velocity of A with respect to B or velocity of B with respect to A. Any value you can find there. So then suppose I am finding this velocity of A with respect to B. So velocity of A with respect to B means which particles we are assuming at rest. So the particle B is at rest here. We are assuming that particle B is at rest. And so now this velocity of A must be directed along this direction here. And so now let us write this. So I am finding this 5 root 3 minus V by root 2 I cap plus 5 minus V by root 2 j cap, right? Just we are finding the difference between these two vectors here. So for collision to take place, this velocity must be only along the line joining these two particles here. So line joining these two particles means it must be along this x direction only. The velocity of A with respect to B must be along this direction only. So this should be the direction of this velocity of A with respect to B. So that means only it should possess the x component of velocity. Y component of velocity should be 0. And so that this term should be 0. From that we can calculate this. So for collision to take place, VAB should be along x-axis. So should be along x-axis, right? And so then you can find this along x-axis means therefore this y component you can write this as V is equal to, directly I am writing here, you will get like 5 root 2 meter per second you will get. So this is our velocity of this point here. That means this value I am equating to 0 here. This y component should be equal to 0. Then from that you can write this value as V is equal to 5 root 2. And now here if they are asking the time also. The time means the time after which it will happen. So then if V is equal to 5 root 2, then you can substitute this value here. Therefore this time taken we can write this as the distance between those two particles by this relative velocity we need to write here. The modulus of this relative velocity we need to write. So here this is 1 meter distance is there and this value is nothing but 5 of root 3 minus 1. Because once if we substitute this 5 root 2 here, then this value V by root 2 value is nothing but 5 you will get. So 5 minus 5 root 3 minus 5 you will get. So this is nothing but our velocity of A with respect to B. And because this y component value is equal to 0. And so you can further simplify this, then you will get this time here. That means the time of which that collision is taking place, right? So that is a condition for this collisions here. Velocity of line joining those two, the velocity of one particle with respect to the other particle must be along the line joining those two particles, then collision will take place. Otherwise they won't collide, they will travel with along the different paths without collision, right? And so now let us take another problem here. And so now let us say this problem. And actually this type of problem we solved already. Let us say this problem here. Two towers AB and CD are situated at a distance d apart as shown. AB is 20 meters high and CD is 30 meters high from the ground. An object of mass m is thrown from the top of AB horizontally with velocity 10 meters per second towards CD. Simultaneously, another object of mass 2m is thrown from the top of the CD along at an angle 60 degrees with the horizontal towards AB with the same magnitude of velocity as shown as that of the first object. Two objects move in the same vertical plane, collide in the midair and stick to each other. Calculate the distance between the two towers. So in projectile motion we already solved this type of problem, right? And so by calculating x displacement and y displacement of those two particles and by writing the relation between them, we mentioned that we already solved this type of problem. Now let us see by using the relativity. So by using this relativity, let us say how to solve this problem here. So just velocity of one object with respect to the other object we need to find here. So right. And so now for example this particle itself I am taking it as A and this particle I am taking it as C. So velocity of A I am writing here. So velocity of A we can write this as in vector form 10 I cap. So this is the coordinate system, usual coordinate system I am taking here. This is x and y, let us consider. And now this is velocity of B, let us write here. Sorry, that is we are taking it as C. So write that as velocity of C. So let us resolve this into component. That means its magnitude is 10 only. The same magnitude it is projected. So then minus its x component you will get along negative x direction. Minus 10 cos 60. So that is cos 60 is 1 by 2 I cap. Plus 10 sin 60 root 3 by 2 j cap. Therefore this velocity of C you can write this as minus 5 I cap plus 5 root 3. Sorry, this y component is also negative you will get because it is below this. So therefore this y component is also negative vector you will get here. So this is I cap and this is minus, right? So this is 5 root 3 j cap. So this is the velocity of this C. And now let us write this. So now let us write this relative velocity here. Suppose I am taking this velocity of A with respect to C I am calculating here. So velocity of A minus velocity of C we need to write. Therefore this value we can write as velocity of A is just 10 I cap. So then this will be plus 5 I cap plus 5 root 3 j cap. Right? Therefore this velocity of A with respect to C is 15 I cap plus, and this value is nothing but 5 root 3 j cap. So now for the collision, this is the velocity of A with respect to C. That means according to our assumption, velocity of A with respect to C means we are assuming the particle C is at rest. The particle C is at rest. Now A is traveling along the direction towards the C to hit that particle. So it is given that they are colliding, or actually here that means the collision is taking place here. When the collision is taking place, we can say that the velocity of A with respect to C must be directed towards the C here. And so that means this velocity must be directed like this. So this should be the direction of our relative velocity here. So that means this is our direction of this velocity of A with respect to C. So let us form this right angle triangle here. I am drawing a right angle triangle. And so now this is our velocity of A with respect to C direction here. And so then this angle you can define this as, suppose I am taking this angle as some theta. So therefore this tan theta I can write this as y component by x component 5 root 3 by 15. So that implies we can write this theta is equal to 30 degrees we can write. That gives 1 by root 3 value. So which is 30 degrees we can write. Right? And so now here our aim is to find the distance between these two towers. Distance between these two towers means just you can use this value, see this is 20 meters and this is 30 meters total height, and so then this distance we can write it as 10 meters, right? And so just to use this triangle here, suppose I am taking this point as some P, then ACE right angle triangle. So let us take that ACE triangle. So from that what I am writing is tan 30 is equal to, so tan 30 is equal to CE by 10 by this BE you can, AE you can write here, that AE is nothing but the D we can write, and so that this D value will be equal to, you can write this expression as 10 root 3 meters, right? So now that is the distance between those two towers here. So you can find it easily, more easily when compared to that of our previous method. So previous method we solved by using our projectile concepts, by finding the x displacement and y displacement of the particles. We calculated we calculated our velocity there, right? So now here we are calculating by using this relative velocity concept here. So then this relative velocity concept will be more easy when compared to that of this, right? And so here let us see such a one more similar problem here. So then an aircraft is flying horizontally with a constant velocity of 200 meter per second at a height of 1 kilometer above the ground. At the moment a bomb is released from the aircraft and the cannon gun below fires at the shell with an initial speed of 200 meter per second at some angle theta. For what angle theta will the projectile shell destroy the bomb in the midair? If the value of theta is 53 degrees, find the minimum distance between the bomb and the shell. Then as they fly past each other, take sine 53 is equal to 4 by 5. That means here first they are asking like for what angle collision is possible. So the same concept, same as that of the previous. Just we need to find velocity of one object with respect to the other object. So this is velocity of the plane. This is the velocity of the it is moving horizontally here. At a moment a bomb was released here. So this is the velocity of the bomb. So let us take this as velocity of the bomb here, which is horizontal, and let us take this as the velocity of the shell, right? And so now this velocity of the bomb we can write as velocity of bomb is 200 I cap, because it is along this direction here. So velocity of the shell is equal to, let us take our usual coordinate system, x and y axis will be like this. And so then velocity of shell is again 200, that means minus 200 cos theta I cap plus 200 sin theta j cap, right? And so now I am writing this velocity of shell with respect to bomb. So velocity of shell, that means we are assuming then bomb is at rest here itself. Now the shell is only projected towards it, that means only shell is moving here. And so then what we can write is this value will be 200 of minus 200 of 1 plus cos theta I cap, you can write here. Vs minus Vb we need to write. Vs is already here, minus 200 cos theta is there, then here it is 200. And plus 200 sin theta j cap. So this is the velocity here. And so now again let us find this direction of this velocity here. That means again for the collision to take place, this velocity must be along this direction here, right? So the velocity of this shell with respect to the bomb, so the velocity of the shell with respect to the bomb must be along this direction for the collision to take place. And so then you can find this value as velocity of the shell, that means the direction. Let us find here this angle, I am taking this as some alpha. So tan alpha is equal to again y component by x component, that means 200 sin theta by mod of this x component we need to find here. That mod of x component is 200 into 1 plus cos theta, right? And this tan alpha value you can write by using this triangle. So in the figure if you observe this side is nothing but 1 kilometer and this is root 3 kilometers. So then tan alpha is equal to 1 by root 3 will get here. So therefore this is 1 by root 3 is equal to, you can write this expression as sin theta by 1 plus cos theta. So by simplifying this equation, you can you can simplify this equation here and you can find this theta values there, right? And so then if it is, so that means for theta is equal to 60 degrees it will satisfy, or you can cross multiply and simplify this equation here. So that means 1 is equal to, I can write this as root 3 sin theta minus cos theta you can write, or this is nothing but you can write this as 1 by 2 is equal to sine of theta minus 30 you can write by dividing with the 2 on both sides and writing this as sin A minus B formula. So this also 30 you will get. So therefore this that means here this is, therefore this theta value will be equal to 60 degrees you will get, right? That is the angle at which this particle is to be projected. And now here the next question what they are asking is, if it is projected at 53 degrees, then find the shortest distance between them they are asking. So that means if it is projected at 53 degrees, then this velocity will be somewhere like this. The velocity will be, that means the relative velocity again if you calculate, it will be along this direction here. Then again find the same value by substituting this relative velocity, you will get the same expression. And just you need to substitute this theta value as 53, which is sin 53 is 4 by 5 and cos 53 is 3 by 5, you can substitute there. Then that velocity will be along this direction you will get here. The velocity of A with velocity of S with respect to B. And then perpendicular distance is nothing but this distance we need to find here. Just we draw the normal from this. And so then we solved already this type of problems in the last class, the finding the minimum distance between them. And so then this is our minimum distance here. Suppose this is bomb B here and this is a point A, let us consider. Now AB is nothing but our shortest distance we need to find here. So such a problems we already solved. And just here relative velocity calculation is also over here. Just you need to calculate this distance here by using our trigonometry. And just this angle is 53 degrees we can use. So it is projected at an angle of 53 degrees there. So right. So solve that minimum distance problem. And so now let us see this another problem based on this relative motion. So let us see this problem now. Say a particle, a point A moves uniform with a velocity v in such a way that the direction of velocity is continually points at the another point B, which in turn moves along this straight line with a uniform velocity u less than v. At initial moment u and v are at right angles and the points are separated by a distance L. How soon will the points meet? And the same problem they will give like they will give it as like a cat and a rat are moving. So that means suppose a rat is moving along this direction and a cat is aiming to catch that rat. And so then the same problem they will give that data like that. So that means the similar concepts we need to write here. That means initially our situation is like, initially the velocity is, this particle is here. It is having this velocity v, and initially this particle, another particle b is here, it is having velocity u like this. So the given information is these two particles are initially separated by a distance L here. The given information is the velocity of this particle A is always directed towards the particle B. So initially particle B is here, so it is directed like this. If the particle B here, then its direction will be along this direction. So like that its velocity will be, changes its velocity continuously. The direction of the particle A changes continuously, whereas the direction of particle B will remain same there, right? And so the particle B is along this direction only. So they are asking that after how long they will meet with each other if initial separation is L. Suppose we are assuming that they are meeting after some time t, capital T we are assuming here. And at any instant of time, suppose this particle A is here and particle B is here. So that this the line joining is making an angle alpha with this x-axis here. So now let us resolve this velocity of B into component along this line joining these two particles here. So the velocity of B along this direction means you can write simply it as u cos alpha. And so now let us write this the distance between these two particles, that means the distance traveled by this along this direction here, line joining those two particles. And so now along the line joining those two particles we are writing this distance traveled in the time t. So then you can integrate this because this value is variable here. You can't write simply velocity into time, you can't write here because this angle alpha is variable here. So that we are integrating to find the distance traveled. So that means that relative velocity into the time we are writing here. So that relative velocity is nothing but you can write this as v minus u cos alpha into dt, integral of 0 to t, that should be equal to L. Now we are separating this integration here, then v into dt is equal to my integral of u cos alpha into t into dt we are writing, and from this we can write v into t. This v is a constant value, so that v into t you can write here, then here just we are writing this u outside because u is constant. But now this alpha is a variable here, so you can't find here directly this value. So we need to find this value by using any other equations. So we are taking this as equation 1, right? So this is the first equation what we are writing here. And next what we will write is the distance travelled. So that means along x-axis distance travelled by the b in the time t you can write here. That means only for the particle b if you are taking, that particle b is travelling only along this x-axis here. When it is travelling only along this x-axis, the distance travelled you can write this as u into t, because it is travelling with the uniform velocity again. So then now similarly the distance travelled by this particle a along x direction. Now for this particle along x direction, how much distance it is travelling? So then both must be same here. For example, if the two particles are let us consider two particles are meeting with each other at this point here. So that means now this particle b is travelling a distance of u into t along this x-axis. So the particle a also reaches this point here. Particle a also reaches that point, means then along this x-axis this particle should travel the same distance here. So now we are using that concept now. So then along this x-axis the distance travelled by this particle means we need to resolve this velocity into component along this direction. So this alpha we are taking as alpha here. So then along this direction you will get v cos alpha. The distance travelled along this x direction by the particle a means integral of u cos alpha into dt you can write. So that is what we are writing here, integral of v cos alpha into dt. So this must be equal to distance travelled by the b along this x direction, which is ut. So then from this you can calculate this integral of cos alpha dt value, and this value now we substitute in our first equation there. That means in this equation we will substitute that value here, integral of cos alpha into dt. And by substituting this ut, vt minus u into ut by v is equal to L. And on simplifying this, you can find this t value here. So the t value, you can write this value as t is equal to Lv by v square minus u square. So it's a very important problem, and just only two equations you need to write here. So then those two equations, one is we are finding the displacement along the x-axis for both the particles and we are equating them, that is one equation. And we are finding the distance travelled along the line joining those two particles. So that is another equation what we are writing. Just by using those two equations you can solve this problem, right? And so now let us see this type of problem. These are also important model only. So see this problem. So then three particles, that means three particles are located at the vertices of an equilateral triangle whose sides equal to A. All the particles starts moving simultaneously with the velocity v, a constant in modulus, with the first point heading constantly for the second, second for the third, and the third for the first. How soon will the particle converge? So that means after what time the particles will meet with each other, they are asking here. So these three particles are traveling here, and here the given information is they are not traveling like this. Suppose you may think that particle 1 is here and 2 is here and 3 is here. Velocity of 1 is directed towards 2 and 2 is directed towards 3 and 3 is directed towards 1. So its information is not like that exactly. So always the velocity of one particle will be directed towards the other particle. Now similar to that of our previous problem. Like in this I said, like rat is running along this x-axis and cat is chasing that. So the direction of velocity of the cat is always directed towards this rat here, or velocity of particle A is always directed towards this particle B here. So that its direction is continuously changing here. So like this here, the velocity of these particles, now all the particles are continuously changing here. So they are not along the sides of this horizontal triangle here. Suppose by the small time interval the particle B is here, second particle is here. Now the velocity of A is not along this direction, velocity of first particle is not along this direction here. The velocity of first particle will be somewhere like this, it will be directed like this. Because now in that time first particle also travels some distance here, right? Instead of here the particle will reach us to this position there. And the second particle is here. Now the direction of velocity of second particle is directed towards the third particle. So third particle is not here. So third particle also travels some distance there, right? And so then velocity of this third particle will be directed like this. So velocity of third particle will be directed towards this, the second particle is directed towards this third particle here. So third particle will be somewhere actually here. So the third particle direction is like this. So that means again they will be at the sides of the triangle only, but the side of this triangle goes on decreasing here. So after some time the first particle direction will be directed like this, second particle will be here, and so second particle velocity will be here like this, directed towards the third particle velocity will be like this. And so always they are at the sides of the vertices, that means they are at the vertices of a triangle only, but that size is decreasing there. The size of the triangle goes on decreasing there, and so that finally they will converge at the centroid of the triangle here. So that means now in the next diagram you can observe this. So now in this diagram you can observe this here. The particles are that means it travels along the sides of the triangle like this, and so actually they will follow the path like this. The path followed by the particle will be practically like this. The size of these triangles will goes on decreasing, and the shape of the triangles also it is like this here as shown in this figure, and so they are meeting at this point here. Now actually this type of problems you can solve in two ways. By using a relative velocity concept you can solve, or by using here I will explain by relative velocity method also. Let us see here how to solve this by first method here. The first method what we are taking is all the particles are converging at the center of this given figure. So here based on the same concept lot of problems will be there. Here like 3 body problem is given, and sometimes it may be 4 body problems, like 4 are at the corners of a square and they are running towards each other, and it may be like hexagon or polygon, any polygon they may give. Like sometimes they will give like n number of persons or there. Direction of velocity of one person is directed towards the other always. That means they may increase the number. Any number of particles you can take more than 2, more than this 3, right? For all those problems the procedure is same procedure we need to follow here. And so there is nothing but here this one way is nothing but in all such a type of problems they will converge or they will meet at the center of the given figure. If it is triangle is given, they will meet at the center of this triangle. If a square is given, then they will meet at the center of the square. Or if polygon is given, they will meet at the center of the polygon, right? And so now here this one of the method here is let us say this one here. So the particles are meeting at the centroid there. Now velocity of this particle along this direction we are writing here. The velocity of particle along this direction you can write this as. And so now see this velocity of particle along this direction is nothing but you can write this as velocity along this direction you need to answer here. So velocity along this direction is nothing but because the particle is initially here and finally it is reaching this point here. So its velocity along this direction means v cos 30 you can write here. So root 3 by 2 v. And displacement we are writing here. The displacement initially particle is here and finally they are meeting at this centroid, right? So the displacement of this particle is nothing but this distance you need to find here. Distance of this vertex from the centroid, which is nothing but a by root 3. You can use, if you don't know that, you can use this triangle, and by using this triangle you can calculate this. Cos 30 you can apply here. This side is a by 2 and then just this hypotenuse of this right angle triangle you need to find, right? And so that is a by root 3 you will get. Now the time taken means the displacement by velocity you can write here. The displacement is a by root 3 and velocity is root 3 by 2 v. So then by using that 2v by 2a by 3v you will get, right? And so now here see the same problem. This is one method. Just we find the velocity of this object directed towards the center of the figure, and we find how much distance it is there between the initial position and the final position. That means center of the final position will be center of the triangle only, or center of this given figure only. So then we find the distance between them, and just we write the displacement by the velocity we write here. The another method is we find the relative velocity here. So let us see by relative velocity method here. So let us see by relative velocity second method. So I will totally remove this. Let us say this second method. So now I am writing this velocity of 1 with respect to 2. I am finding with respect to 3. Let us find here velocity of 1 with respect to 3. So along the line joining those two particles, because they are meeting with each other, they are colliding with each other, means along the line joining those particles I am finding here. So then velocity of this particle if you find here, if you resolve this velocity into components, so along this velocity of 1, along this direction you can find its velocity will be like v1 cos 60. V1 means its value is V1. So I can write this as V cos 60 and its velocity will be along this direction only. That means for this no need of resolving it into components. So its direction will be along the direction directly there. Right? And so that this relative velocity we can write this as V13. This is only along the line joining the particles we are writing here. That means you need to write relative velocity of one particle. This actually we called relative velocity of approach. That means with what velocity the particles are approaching each other. So this term is nothing but relative velocity of approach here. This is along the line joining those two particles only. Remember that. And so now it is nothing but you can write this as V by 2 minus V. So it is minus V by 2. So let us take this modulus of this value here. V13. That means we can say that both the particles are 1 and 3 particles are approaching with a velocity of or with a speed of V by 2. Now therefore the time taken we can write this as the distance between those two particles by the speed of relative speed of approaching here. So the distance between those two particles is nothing but A. We are finding, like, observe this, we are finding 1 with respect to 3 means we are assuming that the particle 3 is at rest. Only 1 is moving approaching this particle 3 here. So 1 is only approaching this particle 3. So that it is approaching with a velocity of, here you need to take this as plus sign, right? So observe this relative velocity. Velocity of this 3 is opposite direction here. If you are taking this as positive, then this will be negative here. Then this value will be plus 3. That means you will get like 3V by 2 you will get this velocity. So this is 3V by 2. So that is the relative velocity of approach here. They are opposite direction. V1 cos, that means V cos 60 and this V value will be opposite in direction here. So we need to add these two velocities. So 3V by 2. And so now here they are approaching each other with a velocity of 3V by 2. And how much distance they should travel for collision is nothing but this particle 1 has to travel a distance of only A. So then A by this relative velocity of approach we are writing here. So you can write this as A by 3V by 2. So which is nothing but you can write this as 2A by 3V. Right? So you can observe that here also we are getting the same answer here. 2A by 3V we are getting. So this will be the general method, and so I try to solve by the second method here. So second method, because we are solving by relativity, by using the relative velocity concepts here, and so you can solve these problems by relative velocity concepts here, right? And so that this is the relative velocity concept. The same concept can be applied for any number of particles there. So right, like suppose here I am giving like for example I am taking these 4 particles and let us see how to solve these 4 particle problems here. So like suppose the 4 persons are there at these corners of a square, and suppose velocity of one person is always directed towards the other here, right? So like suppose here velocity of one particle is directed towards the other and they are traveling with the same speed V like our previous problem. Just the person, one particle is one more particle we are increasing here, right? So like suppose say one particle is directed initially, this is directed like this and this particle is directed like this particle is directed, they are traveling like this such that their velocity is always directed towards this other particle here. The velocity of one particle will be always directed towards this other particle, right? And suppose now let us say this is particle A and particle B, C, D we are taking here, and side of this square is, let us take it as A. And in this also actually they will meet at the center of the square here. They will meet at the center of the square. Now let us solve by this also relative velocity method. So just I am finding this velocity of A with respect to B. This is velocity of approach. Remember that this is the relative velocity of approach. Relative velocity of approach means velocity only along the line joining those two particles we need to write here. Well, relative velocity of approach means. So velocity of A minus velocity of B we need to write here. This is mentioned here clearly. This is relative velocity of approach. This is. So relative velocity of approach is equal to VA minus VB bar you can write. Now VA value is nothing but V and VB value along this direction is 0. Observe this. Velocity of B is along this direction. So its component along the AB line will be 0. And so that those particles are approaching with the velocity V itself. the particles A and B are approaching only with the velocity v. Like suppose this is AB is equal to v. And therefore from this our time taken calculation is nothing but t is equal to distance AB by the relative velocity of approach between A and B we need to write here. So which is nothing but A by V you will get, right? So distance is side of the square is A and the separation relative velocity of approach is V here, right? And so then this is nothing but we can write it as A by V. Now we can solve by our first method also. You will get the same concept here. If you are solving by this first method here, then you will get like the distance traveled, you need to write this value here, and the velocity along the direction you need to consider here. This angle will be 45 degrees you can consider. So this angle is 45 degrees and this distance will be A by root 2. So right. And so now this time taken by using that method you can write this as distance is A by root 2 by velocity along the direction we need to write. Along the direction means V cos 45. That means that is nothing but V cos 45 is nothing but V by root 2. So again you will get this value as A by V. So either you can solve by relative velocity method or you can solve by this method. So then relative velocity, prefer the relative velocity method here, right? And now, so there may be problems like 6 members problems may be given or n number of problems may be given. The procedure is same. So we find the relative velocity of approach of one particle with respect to the other. So remember means approach means along the line joining those two particles only need to consider there. Not the total velocity of A with respect to B, we are not calculating that. Velocity of A with respect to B along the line joining those two particles. Only that components you need to consider there. That the distance between those two particles by like AB we need to write here. So that is a simple procedure to solve these problems there, right? So now here in these problems only sometimes I may ask that how much distance they are traveling and how much displacement they are traveling, they will ask here. Displacement is nothing but the shortest distance between the center of the figure and this vertex of this given figure. It may be square or triangle or polygon, any polygon they may give. And how to calculate that distance travel by the particle. So the distance traveled by the particle in this type of problems will be actually you need to write like you will get time taken value by using this. So displacement is nothing but the distance only. So remember the difference between these two values here. So the displacement is nothing but suppose if this point is center C here, we are using this as C already for this. I am taking that as A. So AO. So remember this AO means distance of center of the given figure from the any vertex. It may be a triangle, square or any polygon, right? So that gives the displacement in any case. And next, whereas if you want to find the distance traveled, so distance traveled. So then distance traveled is nothing but this velocity of the particle into, this is velocity of particle, not any relative velocity here. Velocity of any particle you may consider. Velocity of particle into time after which they are colliding with each other. So let us write it as in general form. Let us write it as a capital T here. So let us write this as, that means this value we are taking it as capital T, right? So that means the time after which they are colliding with each other. So for example, in this case if I write here, so in this square problem, they are traveling with the velocity, that means they are traveling with the velocity v and the time taken is a by v into v. So you will get a only. That means each particle will travel a distance of a. Whereas if you are coming back to this problem and if you want to answer this, and so now here this distance traveled will be equal to velocity of particle is v into time taken by the particle is 2a by 3v, right? And so then it travels a distance of 2a by 3. Now we can observe that this is the distance, and whereas the displacement is this one. Displacement is a by root 3. Distance of this particle from vertex to this corner. So both are different here. Distance and displacement are different. So this is a way of calculating the distance and displacement. So displacement of any particle is always from center of the figure to the vertex. And whereas distance traveled by the particle we need to calculate like this. Velocity of that particle into, or the speed of that particle into time after which the collision is taking place. Just multiply that, then you will get the distance traveled by that particles you will get, right? And so now I am giving some problems here, like basing on this above problem, similar to that above problem. Here I am giving a six body problem. So 6 particles problems here. So solve that problem. and try to solve these problems also by using this relative velocity concepts here. Like an aeroplane is traveling here, two aeroplanes are there. Aeroplane A and B are flying with the velocities, constant velocities in the same plane, 30 degrees and 60 degrees respectively with the horizontal. The speed of A is 100 root 3 meter per second at T is equal to 0. The observer in A finds B is at a distance of 500 and observer B sees that moving constant velocity perpendicular to the line joining the motion of A. If at T is equal to T naught, A just escapes by hitting the B, then find the T naught value. So this actually previous advanced question only. I think it is given in 2014 I think. So then try to solve this problem here by using this relative velocity. I hope you can solve this problem, right? And I am giving some other examples also here based on the general total relative velocity concepts here, because with this today class I am going to finish this relative velocity concepts. So I am giving some other problems also. So then do one thing, solve these problems, right? So then try to answer all these problems there. So if you are not getting, then you can ask me that. I will explain how to solve those problems, right? So practice all those problems based on that, right? Thank you.